So in problem 7, most of the work is done for us. What we're trying to do is find the intervals upon which this function is concave up and concave down. So we know that to do that, we need to get the hypercritical values, and those come from the second derivative, and we just happen to be given the second derivative right here. So all we have to do is set it equal to 0, right? Just ask that first question. So number 1, where is f double prime of x equal to 0? We don't need to ask the second question, right? Because the function itself is a polynomial, always smooth and continuous, no cusps or corners, no sharp points. So we're going to get f double prime of x equal to 0, which tells us that 4x minus 8 is 0, 4x equals 8, x equals 2. There is one hypercritical value here at x equals 2. So I'm going to draw a number line here, label it x, and label my hypercritical value here at 2, and then I'm just going to analyze that second derivative. Now I'm going to put the second derivative up here. Probably no need to factor it, just 4x minus 8. Now, if I pick a number to the left, in this interval from negative infinity to 2, like 0, if I put 0 in here, I'll get 4 times 0 is 0 minus 8. That's negative, right? So I get a negative here. And if I put a number to the right, like 3, 12 minus 8, that's positive. All right, so on the left, second derivative is negative. That means the curve is concave downward. On the right, it's positive, so it's concave upward. So there is a change in concavity here, right? Concave down to concave up. So that 2 is a point of inflection. So to write our answer here, I'm going to say this curve is concave upward. Now it's concave upward where? Where it's positive. So that's from 2 to infinity, open interval, on 2 to infinity, and concave downward where it was negative. That's negative infinity up to 2. There we go.